Without further ado, I want to jump into our first speaker. And so we're going to start off with the presenter, Rohan Sonthalia, who is a visiting undergraduate student working in the Solus Lemus Lab at the Wisconsin Institute for Discovery. And Rohan has interest in both machine learning and software development. Let's all give Rohan a warm welcome.
All right, thank you for having me. Yeah, all right, thank you everyone for having me today.
So sorry, you can skip this one if you want.
Okay. All right, so as Chris mentioned, I work at the Solus Lemus Lab at the Wisconsin Institute for Discovery. And my research topic is basically clustering or phenotype prediction of mycoviruses using transformers and deep learning. All right, so why do we need to cluster mycoviruses? First of all, what are mycoviruses? Basically, we've got a lot of fungi that affects crops, right? And so, the fungi essentially causes diseases to the crops, which does not result in a positive yield. So mycoviruses basically inhibit the pathogenicity of the fungi. So basically, fungi kills plant, but mycovirus kills the fungi. So we've got a plant that does stay healthy. Now, we need to predict the phenotypes or cluster mycoviruses because one, the genome sequences of such viruses are incredibly difficult to align because their sequences are incredibly diverse. Experimental phenotyping of all the possible classes of these mycoviruses is not possible because it's a very labor-intensive and very intensive process. And available data is largely imbalanced. So till date, 90% of the mycoviruses that we do have do not affect the fungi that we want it to. So what is genome sequence aligning? Basically, as this diagram represents, we add dashes or gaps in between DNA sequences in order to get the maximum matches between two or more sequences. So let's say if we perform genome sequence alignment on a set of viruses, we add dashes between the sequences of each virus in order to align them the best we can. And therefore, the sequences that have the most matches allegedly should have the most common properties or should have similar properties. Now, this is just a diagram that represents the different genome structures of mycoviruses. As we can see, there are several genome structures and most of them are very disproportionate. Instead, up to 10% are unclassified. And we've got mycoviruses that have single-stranded RNAs, double-stranded RNAs, and now we have recently figured out that mycoviruses have double-stranded DNAs as well. So, continuing on the topic of inability to align mycoviruses, as we noticed in the previous diagram, there is a wide variety of families of mycoviruses. Therefore, it results in large variable structures in their genomes, again, which results in an inability to align them. And there is a disproportionate number of families that have sequences composed of several genomes, which is either double-stranded RNA, single-stranded RNA, or even DNA. And it was only up until 2010 that we realized that mycoviruses can be composed of double-stranded DNA as well. Now, given that there are some bioinformatic post-processing that can allow us to align these sequences, but aligning the raw data is something that's not possible right now. Now, moving on to the current methods of DNA sequence embedding. Now, what I mean by DNA sequence embedding is basically embedding your DNA sequences into vectors so that those vectors can be pushed into machine learning or deep learning models. The most common method right now is embedding them into k-mers, also known as a process called k-mer counting. Now, k-mer is basically the equivalent of a word or a token in natural language processing. So what you do is you take a large sequence, you define a value of k, and then you break down that sequence into sub-sequences which have a length of value of k. Now, how this exactly works is you start from index 0, you break it into a smaller sequence of 0 to k minus 1, and then you keep increasing the value of your initial index by 1. So a sequence like ACAGT would be broken down into 3 k-mers as is shown in the diagram there. Now, what the k-mer matrix does is let's say you've got your k-mers broken down, you've got your subsequences, and now for every subsequence that is present, your k-mer matrix has a 1 under that, under that k-mer value, and a 0 under the k-mers that are not present. So basically, your k-mer matrix has labels or has headings of every possible value of, let's say, a sequence of DNAs that can be produced with a k-mer value of, let's say, 3. So k value of 3 will have sequences of AAA, ACA, and every possible combination of 3 nucleotides each. Now, the issue with this form of DNA sequence embedding is that for greater values of k, the length of the k-mer matrix becomes too large to compute, because the length of the k-mer matrix is basically the value of k to the power of 4, which gives us all the possibilities of sequences of nucleotides. So for a value of k, let's say you get the k-mer matrix of size 10,000, which again is not ideal for any form of model. And these matrices are largely sparse, again, because you've got a limited number of k-mers that do exist, and your matrix has a really large size. So we notice that these matrices, especially with greater values of k, become increasingly sparse. Now, bioclustering is a web app that was launched by the Solis-Lemus lab. It basically clusters genomic sequences using the k-mer counting method. So you push in your DNA sequences, it embeds them into vectors using k-mer counting, and then it implements traditional clustering methods, that is k-means clustering, GMMs, and spectral clustering onto those vectors of k-mer count. Now, again, the issue with this web app right now is that it's not very efficient because it implements k-mer counting, which often results in clusters that aren't what the biologist needs, that has just pushed the DNA sequences. So our research right now is improving this using deep learning and transformers. So moving on to the most prevalent buzzword of our time, which is large language models. We use transformers and large language models for gene sequence embedding. The current large language models that are available in the market for DNA sequences are DNABird2, nucleotide transformer, and Hyena DNA. So DNABird2 came out of Northwestern University. The nucleotide transformer was developed by InstaDeep and NVIDIA, so we've got big hopes with that. And Hyena DNA was built by a lab called Hazy Research at Stanford University. So our implementation of transformers in order to embed these sequences is basically all we want are the input embeddings from the tokenizer of the transformer. Anything north of the positional encodings of the encoder and the entire decoder is something that we not implement right now. A reason for that is all the 3 large language models that I mentioned in the previous slide have been trained on genome sequences of humans. Therefore, the weights of all the attention heads and the feed-forward networks won't work best with our data sets, because our data sets are sequences composed only of viruses. So since the transformer consists of 2 parts, one is the tokenizer, one is the model, all we do is we push our data into the tokenizer and retrieve the vector embedding that the tokenizer returns. So we don't really focus on the attention heads right now. Now, I'm sure all of us here must have read the paper Attention is All You Need. It was one of the most popular papers that defined how transformers work. But in this case, attention is not all we need, because the attention heads of almost every sequence that I put in the attention mask matrix had values of 1 everywhere, because in DNA sequences, you can't really define which nucleotide is important in a sequence and which is not. So every attention mask comes out to be 1. So what we did was, again, we embedded the sequences using tokenizers. We used the input IDs to train a very basic, a very vanilla multi-layer perceptron in a semi-supervised manner as well as a supervised manner. And again, as I mentioned, we don't use the transformer models right now because they've been trained mainly on human genome sequences. So all of that sounds really good, but another reason why we stuck to input IDs was because we weren't able to get the transformer models working. We could not get nucleotide transformer working because the vocab size defined by the transformer model is much less than the size of DNA sequences in our dataset. Now, there is a workaround this issue. We can break down the DNA sequence into the vocab sizes and then concatenate the input IDs at the end. And another reason we could not get DNA BERT to work was lack of compute. So my CPU constantly kills the worker. A possible solution is I can just run them on CHTC servers. So why do we think that training on input IDs is a valid area or does show promise? Is because I tried them on our current data set using 20% semi-supervised learning and 100% supervised, and this table shows the accuracy that we receive. Now, granted that this accuracy is not very high, we need to keep in mind that this was done with very minimal data pre-processing and the most vanilla of MLPs that you can imagine. So we believe that training on input IDs does have promise, and the accuracy can be improved with better, with usage of better models or with better pre-processing methods. Moving on, since now semi-supervised learning can mean a lot of things to a lot of people, I'll just give a quick overview of my implementation. We divide my dataset into 5 folds. We train our model on the first fold in a supervised manner. And then for all the other folds, we predict the label and retrain the model using the predicted labels. And then we just test the model on the testing dataset. Does this make sense to everyone? Does anyone have any questions here? Yes.
Sorry, what's the prediction? Ask you, what do you predict?
Oh, so sorry. We are basically predicting the phenotypes of the DNA sequences that we have. So right now our data set does have labels, even though in reality it does not. So just to make sure whether input IDs is a valid way of embedding or not, we predict the class labels and then we test if the accuracy is cohesive with what we want or not. Does that answer your question?
Right, okay.
Okay, thank you.
Oh, right.
Yeah.
Is your labeling going to label the entire virus, or is it when you're mentioning phenotype specific proteins or?
No, the entire virus. So we basically label whether the DNA sequence that we have of a particular virus, is it able to attack a particular fungi that we want or not. So there are multiple classes. So we just make sure if it is identifying the correct class or not. Now moving on to other methodologies of embedding, we can use the latent vector of an autoencoder to reduce the dimensionality of either a K-mer matrix or our input IDs. That is one avenue that we would like to explore in the future. And another would be that we can just fine-tune our own transformer. So the current transformers that I showed, especially nucleotide transformer, they have variations that have been trained on genome sequences of multiple species. So we can fine-tune them on a data set of specifically mycoviruses, thereby resulting in a transformer that solves all of this issue. And then we can finally, attention is all we will need then. And then we can use the attention heads and the feed-forward networks to give us actual weights that would make sense with our data. Now, currently unanswered questions are there alternative methods of embedding DNA sequences into vectors, such as byte pair encoding or locality sensitive hashing? Now, byte pair encoding would essentially help us reduce the length of our DNA sequences. And then again, we can implement K-mer counting or autoencoders or our input ID method on it. And locality sensitive hashing does something very similar to byte pair encoding. And the second unanswered question is, what is the actual validity of using transformer models for multi-level classification and or clustering? Because in the end, transformer models also do just return vectors that make sense among each other. And in the end, you do need to apply a separate MLP or a separate machine learning model to make sense out of the data that the transformer returns. And that is all from my side. If you would like to further discuss my research or have ideas on improved methodologies, please feel free to contact me at my email ID. Thank you for your time. I'll take questions now. Yes.
So I wonder if you've tried doing some kind of continued retraining on your the embeddings, like either the input IDs or the auto embeddings. They're clearly not adapted to your process. So what if you had an additional phase of training where all you did was basically a different notion of self-supervised learning, where you can just have the model predict whatever the sequence is itself. It might reduce, it might adapt the model to your setting, and then you can continue with training for predicting the phenotype.
So we haven't yet applied that. Right now, what we did was we just stuck to making sure if input IDs is the way to go. So basically, we just use the input IDs and trained it on what made sense at that time. But what you're mentioning is something that, again, we would like to explore in the future because this is in the very early stages right now. I'm just trying to play around with transformers, make sure that they are something that can be used to solve the issue that we face right now. Does anyone have any? Yes.
So what do the vocabs look like for these models?
So the average sequence length of one DNA sequence of a virus would be around 28,000 nucleotides. But the vocab size of nucleotide transformer in particular is around 3,800 or 4,000. So what the issue that the model faces is that it breaks when I put in an entire sequence because it's not allowed to compute a sequence of that length. So a workaround around that would be that we can break our sequence into multiple subsequences of the vocab size, tokenize them, and then we can concatenate their input IDs at the end.
So the tokens are still K-mers then?
No, the tokens are not k-mers because the transformer returns the input IDs, right? So it's not k-mers, it's a black box model, right? A transformer. So it returns a vector that to the naked eye does not really make sense, but it makes sense to the transformer model.
Right, but still assigns like a sequence of characters like an input ID. It's like a one, it's like a vocab encoding.
No, not exactly. So basically how transformer tokenizers work is that they assign random values to the input IDs at the beginning. And then the transformer model and the attention heads is what makes sense out of those values. So right now, since we don't use the attention heads, we just use the vector embeddings of the tokenizer. I'm sorry, is that making sense to you?
Yeah, okay, I didn't realize.
Okay, thank you.
Yeah,
Yes.
I'm still a bit confused about the purpose. So the reason that you would want to use machine learning is because it's difficult to align
Right.
viral genomes. So when are you using the model, what are you giving it? Are you giving it the assembled viral genome or is it a just sequencing data? Like,
Oh no, it's just raw DNA sequences. You just push those raw DNA sequences into it, and the transformer works its magic and just gives us the input IDs.
okay. And then but you know which samples are like infecting the fungus and which aren't. You just
Yeah.
the genome because it's like difficult to resolve that.
Yeah, right.
So you're trying to predict like which ones, or like in the future, then you could just sequence something. And if your model is like 100% accurate, you could tell whether or not it would infect the fungus.
I mean, so in short, yeah, that is true.
Okay. And then could you resolve like genomic variants that cause that phenotype, or you can only say this one does and this one can't?
I mean, right now we can just say if this one does or this one does not. We can't really solve the issue of the alignment right now.
Okay.
Yeah.
Is there any sort of domain knowledge that should be considered when you're trying to tokenize these sequences, like minimum number of alleles to put in the token?
No, not really.
No,
no.
It's all just.
Yeah.
Gotcha.
Yes.
How big was the CPU that failed?
Oh, it was really small. It was just my local machine. It had like 4 GBs of RAM. Yeah.
So when you do the clustering stuff, could you talk a little bit about how you're validating the clustering?
So again, right now we haven't reached that stage. But again, once we figure out how to get the transformer model working efficiently, that is our end goal, to use the transformer model for clustering.
Gotcha.
Yeah.
Is that work suitable for parallelizing because you have little chunks? You have a lot of mini chunks. Would that be a candidate for parallel computing?
I don't know. I don't know yet. Maybe, I'm not sure. Yeah.
So semi-supervised training,
Right.
so use semi-supervisions improve your accuracy.
So we wanted to try out semi-supervised because in reality, we don't really have a lot of labels. So we just wanted to make sure that semi-supervised is also something that does work. I mean, Does that answer your
Data
question?
set you generate from the first step doesn't essentially give it any extra information, right?
No, it does not. So basically what we do is, sorry. Yeah. So basically what we do is it's a very vanilla implementation of semi-supervised learning. You just break a data set into 5 folds, train the model on the first data set, predict labels for the following folds, and then on every step we concatenate the labels and let's say fold 1 and fold 2, and then we retrain the model, and that's how we go through all the folds.
So are there any informational difference if you just train the model for longer with your original data set, or you just do some random batching or something?
Oh yes, there is, because in supervised learning your data set has all the labels, right? So your data set knows exactly, so your model knows exactly where it's going wrong or where it's going correct. But in semi-supervised learning, after the first fold, it does not have the labels of the other folds. So what you're doing is you're predicting it now. You don't know if the prediction is correct or not. That is validated only when you test the model on the test data set.
So my point is the predicted label is still generated from your label data set at the first step.
Yeah, in the first step, yeah.
So that means it doesn't have any extra information. Are there any difference if you just use the first label data set to do some different batching? Are there any qualitative?
Oh, no, not a lot, no. Yeah.
When you showed in the very beginning that how you do aligning the sequences,
Right.
I noticed you only said like insertions and deletions. Are swaps not allowed?
Traditionally, no, especially in terms of viral sequences, because again, they are so incredibly diverse that you can't really swap a very diverse sequences to align them because it just results in more diversity. So again, this is a specific issue with viral sequences because they have such different structures. Now, there are a lot of things such as horizontal gene transfers that make this even more complicated. But swapping is, as far as I know, I'm not sure if this is correct or not, but people don't usually swap nucleotides in viral sequences to align.
So this is specific for viral sequences.
I think so. I'm not sure. Yes.
What is the connection between what you do and DNA BERT?
Okay. So 1 second. So this is again the architecture of DNA BERT.
Oh, okay.
And what I'm using is I don't use all of this. I just use this part of DNA BERT. Does anyone have any other question?
Are you like, is there just one fungal species that you're interested in? So
No.
These viruses can infect a wide.
Yeah, they can. So again, our data set does have multiple classes. So each class affects a certain type of fungi.
Okay.
This is probably too rudimentary, but have you tried like a word to back model and splitting up the sequence?
I did, but again, so word to vec is something that is very similar to K-mer matrices, K-mer counting. So since we wanted to get rid of K-mer counting, we didn't go that route.
But if the transformer breaking down is might be ridiculous, could you feed the transformer the word to back sequences or the K-mer sequences instead?
Not exactly, because a transformer will again work only if you give it the input IDs of its own tokenizer. If we put in our own data into it without tokenizing it through the transformer, it doesn't really make sense. So in the end, even if you do have word to vectors, you're gonna have to go through the tokenizer. I mean, does that make sense?
Yeah, no, it makes sense, but I guess I'm not totally understanding why the transformer is breaking it, but my suggestion is you could use shorter sequences essentially by doing an initial embedding first and sending that.
Oh yeah, see, exactly. That was the issue with the nucleotide transformer, because our sequence was much larger than the allowed vocab size.
Gotcha.
So the workaround with that issue is breaking down your sequence or into smaller sequences and then again concatenating the input IDs.
Gotcha.
So again, that's just something that we are going to do.
I see.
Would chunking the sequence require you to assign certain weights to parts of the sequence? Like, do some parts matter more than the other?
So again, that is defined by the attention heads. The attention heads make sense of that. You don't, as a programmer, you don't really need to do that.
But do you know, like, if there's a genetic sequence, like one part is actually more important than the other?
Oh, no,
Is it?
I don't know.
Okay.
Like Rohan, want to get once again.
Thank you.
What virus it infect, as long as we have the patches.
It's like.
All right, and now for something completely different. So Michael Roytman will be giving a talk next. And Michael is an undergraduate student earning his bachelor's degree in data science and economics. And last year, Michael started an AI chatbot company that's designed to help people increase their fitness and improve their health. So he's going to be talking about his chatbot and how he's been implementing this. So let's give him a warm welcome.
The right or left?
This side.
Okay. The other one?
We turn your head.
You're great. That's okay.
Ah. Awesome. All right, I think it's awesome. Yeah, hello. My name is Michael. This is completely different from the other presentation. This is a lot more theoretical. I'm very interested in applying machine learning to human behavior, and especially in the sense of self-improvement. So I just want to talk about a couple of my strategies and how I see this extrapolated to a lot more theoretical concepts, and potentially how this could scale and adapt in bigger systems that can help humanity change for the better. And that starts with self-improvement. All right. Oh, there we go. Okay. The problem is pretty simple. Many people want to look better. Many people want to be healthier. Out of a survey done by McKinsey in the United States, United Kingdom, Germany, and France, out of 8,000 constituents, overwhelming amount, about 70% said that they wanted to be healthier, right? So if we all have propensity to become healthier as individuals, why don't we? Well, it's kind of daunting, so many people actually end up quitting. Another magazine called Sun-Dried conducted a survey out of 4,000 constituents this time. Around 43% of individuals say that they quit within the first month. It's kind of sad, but the question is, why wouldn't the prospect of transforming your body for the better be so monumental? It's a rhetorical question. It's very difficult to make that kind of a change in your life. But rudimentary takes two things. Number one, it's the information about how you can do it, aka your diet, what kind of lifestyle you're living, and basically behaviors around that, as well as having the intrinsic motivation to actually implement that kind of a behavior. And if people can't do it on their own, what do? They seek out a personal trainer, just like me. So that's why I started Bollock. It's a personal training business, less like a chatbot, more just general personal business with a twist. So I help people with my expertise and my guidance to basically accomplish whatever steps that they want to take on their fitness journey, because I'm familiar with it and I know what's accomplishable and what's not. But I realized that it would be very inefficient if I attempt to, reinforce that kind of a behavior within my clients on my own, right? Especially as a full-time student and when I have my own commitments. So it would be very difficult to basically text my clients every single day of the week and be able to tell them, like, here, you need to do this and this in order to accomplish this and this. So I thought about automating it. I created a conversational user interface that essentially allows me to create personalized communications with my clients asynchronously, which is very nice. So what is it? Essentially using the power of artificial intelligence, it has the augmentation of like my clients' goals, like specifically like what they want to accomplish, any kind of accolades that they want to see along their fitness journey. Also, some of the doubts, some of the insecurities they might have, and some information about their personal life that, you know, you need to understand as a coach in order to get the point across. Like, how are you going to get through this barrier? And it allows me to do some basic functionality that a fitness coach would need to do, except without me doing it, like tracking your biometrics. I can schedule their workouts for them. I can also give them advice based upon, you know, their personal life, what kind of goals they have, as well as track their usage with the interface. So see how engaged they are on their journey. And while this is, you know, a very cool value proposition for a personal trainer and very fulfilling as an individual that likes the program, this is something very fun to do in my pastime. But I feel like there's a lot bigger potential for this kind of an architecture to be implemented for a broader audience. So let's talk about machine learning. We have used the brain as an example for how to create machine learning models. For example, we have the McCullough-Pitts single layer perceptron within the domain of artificial neural networks. But what if we try to flip the script a little bit, right? What if we think of our brain as a self-supervised learning model? Basically, you can learn pretty fast without getting explicit reward labels within complex and dynamic environments. And using model planning, you can have adaptation to different reward functions within these brand new situations. For example, you are not in college and then you go to college, so you have completely different preferences and your decisions completely change based upon those preferences. So you adapt very quickly to that situation, and what's good and what's bad to you quickly changes. Just an example, very rudimentary, right? So the question is, how is it possible to implement a reward mechanism that can aid the development of generalized decision-making abilities, especially in the environment of health and fitness? Well, let me just walk you guys through my tech stack. So we need to start with the plan. And the plan is very simple. It's a workout program. This workout program has three main components. Number one, it's how I can get the personalization aspect across. I have the nutrition outlook for all of my clients that includes calories and the macronutrients adjusted around that. That is using a Google app script that I have made exclusively for my projects. And basically their information as an individual, right? Like how they're living their life, right? What they want to accomplish, why they can't get to their goals. And this is very important because it becomes a place where they can confine. It becomes a place where they can be able to trust enough to put down what their fears, their doubts, and insecurities are, and how especially the model can reinforce positive behaviors to bypass those. Also, we have the workout program itself, which I just do for fun. I really enjoy doing this. And then body weight. Body weight is really good for tracking in terms of seeing your progress, especially if it comes to like losing fat, gaining muscle. You have to be able to lose or gain body weights to do that. So pretty simple. Now, for the bread and butter of the program, it's the CUI. The driving component of the CUI is an asynchronous microservice. So that asynchronous microservice,
What's the CUI?
a conversational user interface. I'm sorry. Yeah, so it's a chatbot, like you said, within your text messages. That's what makes this very cool, and that's what makes this very personable. There is no other interface besides Google Sheets and your phone. This is an entity that texts you every single day. So how does it start that messaging? Well, there's an outgoing text with a webhook, and it involves a large language model chain that takes context from Google Sheets with like all of this part, all of that part. It uses a prompt ensemble using both chain of thought, directional, and summarization techniques. So basically be able to reduce it to very key components, generalize it, take the keywords out, be able to use those keywords in construction of a response with a certain persona, and then giving to the user. Basically prompting you to do whatever you want to do on your fitness journey that's very specific to you. Like in my sense, I used, the name of an IFBB pro bodybuilder. I used a serial motivator, like a fitness model, and like Tyler Durden from Fight Club. And it knows that. Like I want to be able to mimic these individuals, and this is the kind of inspiration that I want to receive. But it's very different for many different people. So that is an outgoing text message, but the messaging service itself, right? It's containerized. So there's like, you can both like get the messages themselves, and then you can post, aka the messaging service posts it to the person's text messages. And what it has is first a small language model, which serves as a classifier. And it has a very comprehensive few-shot prompt example, which allows it to basically be able to recognize the intent of human behavior that I would essentially want the client to be able to engaging in. For example, we have tracking, like I said, be able to track or be able to like a biometric or some sort of progress that you have in your life. Like say, hey, I did really well on this exam and I'm going to keep up this behavior because it makes me feel really awesome. And that can, be logged in your personal information. You also have scheduling your workouts, like you can see your workouts in demand, so that will just go into its own intent. And receiving advice based upon this kind of information and your previous history of personal life, like whatever, how large the context window is, it doesn't matter. Like it will just adjust. And yeah, and then that would go into a large language model, which serves as an agent that is also augmented with context, and then be able to send text messages based upon that very specific conversation flow. So how does this relate to the brain as a self-supervised learning model? Well, I want to think of the CUI, the conversation user interface, as a reward model in our case, right? So the microservice can be in a model-free based policy where it is prompting you to basically seek out an action without knowing what the consequences of that action will be. That way, you are directly prompted to do something that is good for you without actually knowing that it is good for you, right? Why do most people start working out? They start working out because of external motivation, not intrinsic motivation. It's very difficult to be able to spur a positive feedback loop of habits when you're getting reward for those habits via social pressure or via the mating hierarchy. So in order to realize why something is innately good for you, you must find fulfillment and you must find meaning in it. So getting prompts to do something, why don't you do it? And then once you start to basically retain autonomous behavior within those habits, you start realizing, okay, this feels awesome. I really like taking a cold shower in the morning. I really like going for a run in the morning. It makes me feel awesome. I like going for a workout after my classes. This is good. Now we can shift into a model-based policy. In this sense, we have basically all the functions that you would need to help out on your fitness journey. If you want to schedule your workouts so you don't have to worry about the fact that how am I going to do this? When am I going to do this? Also, with what resources am I going to do this? I can provide it for you. I can just give it to you. It's very convenient for you to be able to incorporate that behavior now, as well as tracking your progress. You can now have a quantitative way of measuring whether you are adjusting to your fitness goals and whether you're actually seeing some sort of results. And also, it would be like a positive mental drift. If you have your personal information being logged all the time, then you can basically be able to see how your mindset has changed as a result of this fitness journey, and you can have a non-biased validator be able to perceive it for you right there. That way, it's the best of both worlds in terms of being able to promote sustainable mindset for growth and wellness. And part of this architecture takes inspiration from this paper over here. Can I just click it? Can I click it?
No, it's not a touch screen.
Oh, really? No, I mean like the link.
Is it a picture?
It's a link.
Oh, sorry, we converted to PNG. So.
Oh, okay. That's fine. That's fine. Where they talk about using a mixed space policy for a model-free reinforcement learning mechanism for long-run horizon dynamics. So, yeah, basically, that was my inspiration for this. This paper came out in like May 30th, I believe. So I was taking a look at it and how you can mix both the model-free policy and model-based policy in terms of reinforcing positive human behavior within the brain. And then, let's see. Yeah, some of my limits, number one, it's scale, because I'm using the Google Cloud API services. It's very difficult in order to scale over like 100 plus clients because there's quotas for reading and writing values. So it would be pretty difficult to maintain this kind of architecture at a very large scale. So we would probably have to shift to something different. And in this case, it wouldn't be Google Sheets. It would probably have to be a real backend so that my clients can see. So maybe like an application for the iOS. Also, as you guys may know, inference from large language models is kind of expensive, especially when we're dealing with very small data and we need very high throughput. So looking into privately hosting an instance somewhere or using an already virtualized privately hosted instance. For example, I was taking a look at Olama the other day. Yeah, it's a pretty good virtual assistant. Yeah, and another problem that I get to is a limitation of personnel. It's pretty difficult to do this. It's like a two-man show. Like developing, being able to do business development, being able to do marketing, being able to do outreach. It's pretty hard, but it's very rewarding. And I really enjoy doing this. However, you can't just like give this thing full power in order to be a coach because it lacks key components of understanding human behavior and actually getting insight from clients' lives. So that's why it's a semi-automatic coaching service. Future integrations that we've looked into in order to be able to personalize it better and make it, a lot more customizable to each one of our clients' experiences. Number one is a vector store for retrieval augmented generation, which is also very difficult to do so, especially when we're dealing with a gateway window. So for our messaging service, which we're using Twilio for, we have a limit on how long we can basically generate responses, which is about 15 seconds. So it's very difficult to use a very elaborate agent, especially if it has any external functions built out into it, and prompt and solve to be actually able to reason and generate responses. So that's also in the works. It's just very difficult to do as a two-man team. And also progress visualizations, be able to send clients, how they've been performing over the course of their journey, and also being able to send them sentiment based upon their previous notes, like measuring like up and down, if we can use like a 0 to 1 continuous scale or a 1 to -1 continuous scale, and then basically be able to show a bar chart over the course of a certain time period. Another way that we can envision this service is to be able to extrapolate it to a larger audience. Like I said, shifting from being able to cater to the consumer exclusively to being able to cater this to coaches that already have a platform, which would be pretty cool. People who already have a lot of clients, but they don't have a seamless way to integrate consumer experience into their communications. The real progress happens outside of the gym. It happens in your brain. It happens when you're studying. It happens when you're going for a walk. And it's a pretty important thing to stay in track of, and many personal trainers don't, or it could be extrapolated to. influencers and individuals who actually have very large following and engagement on social media. And it would be pretty cool to see that brand persona actually be built out into the customer experience platform as well. So it's almost like if you have an individual who's super popular, you can use their persona to be augmented into the context of the agent and be actually able to serve as an extension of that persona, like through text messages. It'd be kind of cool. So yeah, that basically concludes my presentation. I'm very glad to have spoken here today. I really appreciate your time. And all I ask for you all today is to do something that challenges you. And yeah, go outside of your comfort zone. It's very nice to do something that makes you a better person. So yeah, thank you. I really appreciate it. Some of my context over here. So yeah.
What's your first target audience?
What's my first target audience?
For me, it looks like it would be college students.
It is college students, yeah. College students.
Do you have already like clients?
I do.
Results?
I do, yeah.
With progress?
Yes, with progress, yes.
So on your tech stack diagram, I noticed that you've got a large language model called using data from your Google Sheets.
Yeah.
So how do you parse that data from Google Sheets into your prompt? Are you reading that Google Sheet as a JSON file and then passing that JSON file to your large language model? Or?
No. So there is like a JSON interface. Like you would basically so using Google Sheets API, you would have to pass like a JSON format for reading in like a batch of cells or a range of cells. It just depends on, there's a different method resolution order, different data structures, but it's a very matrix heavy oriented language. So you can use a lot of NumPy and a lot of pandas to be able to parse it. So essentially it allows me to get a matrix of however many text values, right? And then I can, there's ways of loading it in. Like I have a custom loader class. I've also used a framework called LangChain, if you've heard of it. LangChain is just very performance expensive, especially when I was talking about sending outbound text messages. It takes more than 15 seconds to generate a very detailed text message, especially if it has multiple points of context, like their diet, like their workout routine, and also being able to extrapolate like something really far back, such as, I don't know, their girlfriend broke up with them. So it's just like a huge context window that you have to look at, and it takes a lot more than 50 seconds to do so. But yeah, essentially like a data loader pipeline, and then be able to put it into like a summarization prompt, and then just use chain of thought to reduce it, find keywords, understand like what the user wants directly, put those keywords into like the classifier, and then classifier essentially allows me to segue into a certain conversation flow.
So have you considered using knowledge graphs to bypass this whole
knowledge graphs? Yeah, I have. Have you heard of Elasticsearch?
Yeah.
Yeah. So I have. It's just, it's not like I haven't tried it. It's just, it's very difficult to do so as a two-man team, especially if you're taking classes. And it's like, you really want to say if it works, but you cannot get complacent, and you really want to implement new solutions. Like originally I didn't want to use a small like model as a form of a classifier because it's also computationally expensive. Like I wanted to use a form of canon as well to be able to match like to a certain intent, but lazy learning wasn't the best in this situation. So I just reverted to using a large language model. I also tried weighted cosine similarity, which wasn't the best as well, but yeah.
Thank you. So I have a question on how you recommending the activity for your client. So is that all based on the prompt you give to ChatGPT? Basically, I can put the prompt in ChatGPT into suggestions, or you have other physiological based models that can give me precise recommendations.
Right. So the advice is more behavioral than it is in terms of sound scientific advice, which is what I really want to use a vector store for. in order to be able to context match that exact bit of information that you need. For example, whether it be a certain nutrition protocol that you can just pull from a PubMed article, and then you can use the whatever context the individual provided regarding like what kind of a diet they eat, such as I'm vegetarian, right? I need to be able to hit my protein content. It would be able to look up the best vegetarian protein sources based upon their amino acid content and protein density, and then be able to match it together and be able to provide the information. But so far it's more of it's more general, right? It's just using a good prompt ensemble, which took a lot of tries, and it's based upon the client information themselves. So like if they don't explicitly say it, it will not be mentioned.
So this is extremely text-based, so the client receives text, right? So it's all wordy, so some people don't respond to words as well. But something that might help improve systems is to watch extremely powerful commercials. I also never watch TV anymore because there's too much commercials, and I'm also from a foreign country, so I don't respond the same way. But the last one I saw doesn't mean I would like it, but it was the Pepsi no sugar, and there is no words. They just influence people with music and designs, but there's no words, and this is what power is. So you should look into that on how you can, if you want to influence those people,
That would be good.
them to self-influence.
Yeah.
But I don't respond well to text, and I don't like to receive texts either. But these commercial thing, Pepsi or Coca-Cola, these big brands, this is where they influence people against their own health.
Yeah.
Right? Because they make them drink these things that are bad for them.
Yeah.
Right. So that's something you should think about.
Definitely. Would you prefer if it was like a real person made that ad, a real person actually directed it, or if it's like AI generated?
The AI generation is not, for me, I don't like text. I mean, I'm an old guy.
Yeah, but if you see like a bunch of gibberish in terms of like stuff just flowing across the screen, or like a coherent advertisement, So if I prompted to say something.
What I'm saying is that these commercial, the one is currently now going on television.
Yeah.
Television. So there are people dancing in the background. They show the big Pepsi logo, and then it's like it's actually drawn on a big speaker.
Okay.
You see boom, boom, boom. There's no words, or virtually no words.
Yeah.
It's like bringing some feeling. I don't respond to that, but I know Americans do a lot. And way too much. And so if you want to really influence people, you should look into that.
Yeah. We'll
That's
definitely
my
look into it. I'll definitely look into it.
Is your hand up?
It's my hand. Pretty hand. You said you're like a two-man team?
Yeah.
What's your ideal team look like?
I'd like to keep it small because I like to have like a good personal relationship with my developers. And there is a lot of miscommunication, especially over the summer, because I'm also thinking going down the corporate route, and it's very difficult to give up on your passion when you really want to work on this like your entire life and you really want to help other people. So I really want to have somebody who's just as passionate, or at least not more passionate than me, and who actually sees this as something monumental, something that can help other people. And that's why I have more broad horizons for this. And I think that this could apply very well to systems that have a lot more scale. So,
yeah. Thanks for a great talk. It's a really impressive stack you built here. I was wondering if you could talk a little bit about some of those points that aren't fully automated. If you have any case studies.
Yeah.
Is it the texting you have to review? Or...
Yeah.
Yeah.
Well, it's usually like repeat offenders. It's like when an individual has a behavior that they adhere to that they know is bad and they still do it. For example, it could be obnoxious drinking, which is synonymous with catabolism, catabolism, like the loss of muscle instead of the gain of muscle. So, and I have to be able to reassure that individual that like, hey, you are doing this habit, like this is your own doing. You are putting yourself forward in order to go against your progress, go against like what you believe in. And it's very difficult to do that through an interface that doesn't really have emotion. So I spent some time researching how you can essentially help a model gain humor and help the model gain emotion, but it doesn't do really well in terms of when you give it like a bunch of few shot examples of like jokes, and then you ask it like, hey, give me a joke. And essentially it gives you like a refurbished version of two jokes together. And you're like, oh, well, this is funny, but I don't see how you can actually come up with that kind of a humor, you know?
Gotcha.
Yeah. So that would be a very interesting component, actually adding emotion. That will take a lot more reading on, and that will take a lot more implementation, but that's also a goal for something in the future.
Yeah. Some folks working on like health and medicine chatbots too might have similar papers on the subject.
Yeah.
Yeah.
And if you guys know anyone working in a very similar domain, I'd love to hear more from the experience.
I think you can put the system message into your chat OpenAI API. So basically you can control how it behaves. So for example, you instruct the OpenAI API to use a system message, or you are a humorous personal trainer that
Well, that's what I did.
some joke, something like that, and then you give it the user prompt, it may do something what you need.
Yeah. It's just like it widely depends on the context. Like sometimes it literally, as much humor as you can provide, it will not be humorous, or like in a very specific detail, you can give it an explicit example and it will be like spot on, and you're just like, oh, I wonder how that happened. But yeah, for that you can also use knowledge graphs or just deeper augmentation in terms of knowledge, which is definitely something I'm looking into.
On the psychological aspect of it, are you using like theories like the theory of reason action or planned behavior to?
Yeah, so React was the original paper that got started in terms of actually planning the logic for prompt sequencing. So like being able to reason based upon client context. And then I would just manually insert it. And then I tried chunking the prompt itself, which gave me sort of better results. But then I ended up doing chain of thought, which was a lot better, especially if I had multiple resources and I had those resources defined. But most inspiration for this actually comes from self-determination theory, and in terms of how we can convert extrinsic motivation to intrinsic motivation and be able to spur autonomous self-behavior when it comes to particularly health and fitness.
And I was also, you might be connected to these resources too, but have you talked to like the Small Business Development Center, Starting Block, Design to Product?
Well, I was in D2P and I was also in CS Nest looking.
So do you store the text that your customers send to your chatbot?
Yes.
Where do you store them? Is it like, again, in
the sheets themselves?
Okay, you store their text in sheet.
Yeah. It's an all-purpose lightweight database that's also serves as an interface, so it's very convenient, right? This was not meant to be production ready. This is like a very, very, very small business esque. It makes a lot more sense for me, and it's very convenient. I've also explored using NoSQL databases. The lookup time in like MongoDB is log n, so it's pretty convenient, but that was a parallel issue for a while because you couldn't toggle multiple resources at the same time. So I had to pivot the web framework that I was using, and it was not very pleasant. So I just stuck with having everything be Google Sheets.
So are your Google Sheets controlled by you, or are they controlled by the user? Because if they're on the user's account and you're accessing their API key, that means the Google Sheet is shared publicly, right? So
Oh, well, it's both. So basically, I have a service key or a service account. That service account is basically an automated manager. It has access to all of my clients' workout programs, and then it can serialize, it can write, and it can also delete content from those sheets.
Okay, so that sheet can be a private sheet on my account, only
Yeah.
with you having access to it.
Yeah, it's a private sheet on your account. It's just shared. You're an owner. Yeah.
Yeah, the way the people, they say that by the time you're 3 years old, you know what you like to eat and this kind of stuff. There's a lot of unconscious things that make you make a decision.
Yeah.
Right. So having an understanding of what's going on in the background, how I saw the title of the book I started to read. It's called Before You Know, Before You Know It. It explains how all your upbringing, in your early years kind of determine a lot of the things you do without even understanding why you would do that.
Yeah.
So I know I like tomatoes, or I like, there are things I like. And because I'm a different country, a lot of things I like are different than what people like here.
Right.
There's a huge background of, and this is what these commercials I'm talking about. So I think it's an important thing to, you have done an amazing work. I mean, on different levels in the psychology, in the computing, and putting that together is very impressive. But I think what I just told you might help, looking into that, the unconscious and the chatter in the head. There's a place called the Center for Healthy Mind.
Yeah.
Here on campus.
Yeah.
And they are developing, and they have developed actually an app that they make freely available to people to help. So if you should contact them too, because they might be interested in what you do.
Yeah. Do you know any connection? I think my professor does research there. I'm not sure if he's in their group.
I don't know. I know Richie Davidson, and so I know a couple of people there. We're just friends. It's not work related.
Oh, okay.
So I know of them, but I was thinking, know of them, and if you need, to get, contact, I can help.
Yeah, that would be super awesome. Yeah.
Well, we're like 8 minutes past.
Oh, yeah.
If anyone has more time, you can get the coffee tomorrow morning.
Yeah, we'll be.
Okay, cool. So tomorrow morning, room 1145, you can come talk to Michael. Thank him one more time.
Okay, thank you.